So today we add up the area of an infinite number of rectangles. Okay. The idea is that we would like to find the area bounded from A to B of f of x. And in calculus, we have a way of expressing this. And we actually use something called a definite integral. The integral symbol looks like this. Okay? We put the bounds at the top and the bottom. A, B, of f of x, and we put a dx on the end. Now, you don't necessarily know what that expression means right now. I'll write it again, but I wrote it inside this area piece so you understand that means area. So the integral a to b of f of x dx is actually equal to something that we know how to compute. We know how to compute the area of rectangles, don't we? And what we did is we took the sum of the heights times the width, correct? So we're going to do the sum of the heights. Do you remember that symbol from last year? It's a Greek letter. Sigma. It is the Greek letter sigma, and sigma for sum. It's the sum. Okay. So the sum of f of x sub I. What x sub I means is it means you're plugging in x values to get the heights. I mean, that's kind of what we've been doing, right? We've been finding different x values to plug in to get the height. So that's just the different x values we plug in. So we have the sum of the heights times the width, right? What we use to represent width is delta x. So that's the capital letter for delta in Greek. So we are going to start at I is equal to 1. We're going to start at our first rectangle, and we're going to go to our nth rectangle. Yeah. And furthermore, we would like to say now that we are not going to do a finite number of rectangles, but we're going to do an infinite number of rectangles. So we're going to look at the limit as n goes to, in fact, infinity. Sorry. So let's learn what that means. Let's learn what that means. Suppose you're finding the area under the curve x squared bounded from 0 to 4. Area under x squared bounded from 0 to 4. If you're finding the area of 8 rectangles, what's the width of each rectangle? How'd you get that? Yeah, you took 4 minus 0, right? And then you divided that by 8. And you got 1/2. That's the width of each rectangle. Would everybody agree? Okay, if you are finding the area of 8 rectangles, at what x values do you evaluate the heights? Now, we're going to choose to use right-hand sums. If you end up doing an infinite number of rectangles, it really doesn't matter whether you do right hand or left hand. It'll come out exact either way, but we're going to focus on right hand. So if the width of each one is 1/2, how do you end up determining where you evaluate the heights? What's the first one you evaluate the height at? 1/2. What's the next one? 1. Now, I'm going to write that slightly different. I'm going to write 2 times 1/2, which is 1, correct? How about the next one? 1.5, or 3 times a half. Agreed? How about the next one? 4, or I'm sorry, 2, which is 4 times a half. And you're going to continue on and on until you get to what? What's the last x value that you evaluate the height at? 4. Everybody agree 4? Which is 8 times a half. We're going from 0 to 4. There's 8 rectangles. We start at a half, then 2 halves, 3 halves, 4 halves, all the way up to 8 halves or 4. You okay with that? Good. So here's the important thing. As you look at this, this is I equals 1. That's I equals 2. That's I equals 3. That's I equals 4. That's I equals 8. We move along and along and along. Given different, I represents the rectangle number that you're at. So if you look at this symbol right here, it says we start at I equals 1. That means we start with the first rectangle, and we go all the way to the end. Let's try thinking about number 2. Suppose you're finding the area of x squared bounded from 3 to 4. 3 to 4. What's going to be the width of each rectangle? 1/8. You took 4 minus 3 and you divided it by 8 to get 1/8. If you were finding the area of 8 rectangles, and what x values do you evaluate the heights? Where are you going to do the first height? No. 3 and 1/8, right? 3 plus 1/8. You're starting at 3. You go over 1 width. Where's your next spot going to be? 3 plus 2/8, or 3 plus 2 times an eighth. Where's going to be your next one? 3 times an eighth. All the way until you get to 3 plus how many total rectangles? 8. So 8 times 1/8. What is 8 times 1/8? So you end at 4. Exactly. Because you're supposed to end at 4. This is where you get to make the connection. This is the super important step. So if you don't see it, please ask me. Suppose you're finding the area under the curve x squared bounded from 3 to 5. If you are finding the area of n rectangles, what is the width of each rectangle? Very good. 5 minus 3 divided by n, or 2 over n. Everybody see how I tried to set you up for that? So this is what we would call our width, delta x. In fact, we say that delta x is b minus a over n. It's your ending of the interval minus the beginning of the interval divided by n. Now, this is more challenging, but this is super important. Lean in. If you are finding the area of those n rectangles, at what x values do you evaluate the heights? Think about what you did. Where do you start? We started 3 and you move over how far? Plus 2 over n. Excellent. That's going to be your first spot. 2 times 2 over n. Good. 3 plus 3 times 2 over n. Good. What's your last one? 3 plus how many rectangles? N times 2 over n. Look at that. What's n times 2 over n? It equals 5. Yeah, you're done here at 5. So these are what we call our x sub I values. What is x sub I? X sub I is the beginning, or A. So we started at 3. That's our A value. And we added onto that the width, which is B minus A over N times I. I represents which rectangle we are using. Now you are ready to add up the area of an infinite number of rectangles. Are you ready? Thank you for your enthusiasm. I used to have this practice with 4. Because you are an exceptional group, you don't need to practice 4. You'll be able to do it with just n rectangles right away. Here is the problem. We are looking at the area of underneath x squared, bounded from 0 to 2. So I will simply just draw the picture here so you can see it. That's x squared. We're bounded from 0 to 2. That's what we're looking for. That is the area that we are trying to decide. When you're trying to find area, it's always important to decide these two things. Number one, what is the width? If I'm going from 0 to 2 and I want n rectangles, what's the width of each rectangle? 2 minus 0 divided by n, which, as you said, is 2 over n. That is what we call delta x. Lock that in. For what x values do we evaluate the sum? Where do we evaluate the heights? Well, where do we start at? We started at, okay, right, so we started at 0, right? Yep. And we move over one width, which is 2 over n. And we take that and we multiply it by I to represent how many widths are we moving over? Which rectangle number is this? So in other words, x sub I is equal to 2 over n times I, or 2I over n. Once you can get these, you can do the rest. The rest is just algebra. That's all it is. So let's write the problem that we are trying to now accomplish. We did the legwork. We're now trying to say the area from 0 to what? 2 of the function. What's the function? Of x squared dx. That's what we want to be able to do. You don't know really what that means yet, other than the area bounded between 0 and 2. We're going to teach you what it is later on in calculus. Won't take much more than a week for us to get there. Is equal to, we're going to write this as something that we know. We know how to find the area of rectangles that we add up. And we say it's the limit as n goes to what? Infinity, which is crazy to even write that, but we know how to do that because we're really smart. Of the sum from what? We're going from the first rectangle to the nth rectangle of f of x sub I. Oh boy, what does that mean? I know you're going to freak out when you think of this thing, this f of x sub I. Do we know what x sub I is? So take that and plug that into your function. So it becomes 2I over n squared. Times, what's the last piece? Do you remember what we wrote? Delta x. What's delta x? 2 over n. Anybody curious about how I came up with any part of that? Are you okay? All right, we're going to figure this out. Limit as n goes to infinity of the sum from I equals 1 to n. I'm going to square that. What's 2I over n squared? Okay. Thank you. So Ashler did something that we would say that I squared would be -1. In this case, when you have summations, I is simply referring to just a variable, not to the square root of -1. But that's a good question. I take issue with it. I'm going to talk to those people who did that 400 years ago. We're going to get to the bottom of it. Okay? So let's look at what we get on the top. We get 4I squared times 2 is 8I squared over what's going to be in the denominator? Times n will be n cubed. Here's a hint. Normally the I should be 1 power less than the n. Okay, so that should pretty much, yep. Now, what I'm going to do is I'm going to factor something out so I don't have, notice I have 2 variables, right? We don't like to have 2 variables. We like to have 1 variable. So I'm going to write this as the limit as n goes to infinity of 8 over n cubed times the sum from I equals 1 to n of what's left after I take out an 8 over n cubed, I squared. Use the algebra. Here we go. These are the 4 summations you need to keep in mind. We flip back to this spot. Let's do it. I've got to get rid of that guy right there. So I need to substitute a known sum. So I have the limit as n goes to infinity of, I have 8 over n cubed. Tell me, what do I put in place of that summation? Excellent. You've done all the difficult work. It is super easy at this point. Let's just follow the algebra. The limit as n goes to infinity of, let's multiply the top out. I'm going to have an 8n up top there times, I'll FOIL this guy, 2n times n, 2n squared. What am I going to get in the middle? 3n plus 1. What's in the denominator? 6n cubed equals the limit as n goes to infinity. Let's distribute that 8n through. What's that? What did I do? This guy? I'm going to start writing again. Okay, so I'm going to multiply the 8n through, and what do I get? Plus all over. Hey, did we once upon a time learn how to deal with infinite limits? Yeah, what did we do? We factored what out of the top? N cubed. Factored n cubed out of the top. What were we left with? 16 plus 24 over n plus 8 over n squared. I'm going to pause to let anybody catch up so we can then all have the dramatic effect together. Over what? 6n cubed. What happens to the n cubes? Cancel. I'm going to let n go to infinity. When n goes to infinity, what happens? Those go away. What are you left with? Which is exact area, 2.6 repeating, or 8/3. Yeah, let's give that a round of applause. That is, folks, you just added up the area of an infinite number of rectangles. Now, take out your calculator so I can show you how we can check our answer. You are going to want to be able to do this. Trust me. We go into y equals, what's our function? X squared. Watch this. I'm going to press zoom 6 for zoom standard. Do you see the picture of x squared? We're going to calculate the area. I go second, calculate. Which one of these do you think I select? Does 7 look like something we just did? Yeah, we select 7. We go from 0, enter, to 2. And look what your calculator does. It draws the rectangles, 2.6 repeating. Second, calculate. Number 7, 0, 2.